Number 3. Consider a sample of 10.0 grams of the gaseous hydrocarbon C3H4 to answer the following questions. All right, so we're going to keep referring to this 10-gram sample of C3H4. A asks, how many moles are present in this sample? Well, I am going to need to connect these grams and moles of C3H8 in order to answer this question. So I'm going to need the molar mass of C3H8. So I need a calculator over here. Got a little spare space for myself. I have 3 carbon atoms. I have 4 hydrogen atoms. Okay, multiply those numbers by the masses of each individual atom. You get 36.03 grams due to carbon, 4.032 grams due to hydrogen. Add them together, I get a molar mass of 40.06 grams per mole. Now I can use this value, grams per mole, to set up my conversion factor. So I start with my 10.0 grams of C3H4, sorry. Goodness gracious, why did I write 8 right here? That's these values are right. I don't know why I wrote 8 a couple of times. It's actually C3H4. Hopefully that doesn't mess you guys up. Anywho, I know I'm going to have grams of the C3H4 on the denominator because they need to cancel out with the units that were given to me to begin with. I know I'm going to have moles on the numerator because that's the unit that I need to end in, right? So that tells me to put the 40.06 value number on the numerator, the 1 on the numerator. This setup tells me to divide these two values, so I end up with my 0.250 moles of C3H4. B asks, how many molecules are present in this sample of C3H4? So I take my total number of moles of this hydrocarbon, and I'm going to use Avogadro's number to convert from the moles into molecules. Right? So the Avogadro's number is 6.022 times 10 to the 23rd molecules. Right? This is in your notes. Moles cancel to leave molecules as the only unit. All right? This setup tells me to multiply these two values, so my final answer is 1.51 times 10 to the 23rd molecules of C3H4. C then asks me how many carbon atoms are present in this sample. Well, I start with the number of molecules that I have. Because I know that for every 1 molecule of this hydrocarbon, there are 3 carbon atoms. How do I know that? Because the formula is C3H4. For 1 molecule of this, notice there's 3 carbon atoms. So that actually becomes my conversion factor. And my final answer is 4.53 times 10 to the 23rd carbon atoms. Then we'll end with D here. What is the percentage composition of hydrogen in the sample? So percent composition. And again, just so you guys can see it, here's my calculation for the molar mass of C3H8. I'm being asked for the percent composition due to hydrogen. Right? The total mass due to hydrogen is 4.032 grams. So I'll take that value, 4.032, right? Mass due to hydrogen, divide by my total mass, multiply by 100%, and I get 10.07% hydrogen.